today's lesson, I'm going to introduce what is pH value and how we can calculate and measure pH value. So in order to understand what is pH, I need to tell you a piece of information first. So although water is a covalent compound, but actually water would ionize and undergo a reversible reaction to release a small amount of H plus hydrogen ion and some hydroxide ion. Okay, so all aqueous solution which use water as a solvent would contain hydrogen ion and hydroxide ion. So for water, we say under normal condition, it is neutral, pH at 7. So that means we have equal amount of hydrogen ion and hydroxide ion. Okay, that's for neutral solution. For acidic solution, it will have more hydrogen ions than hydroxide ion. Okay, so you need to bear in mind, although it's in acidic condition, we still have hydroxide ion, okay, but much less than the hydrogen ion in the solution. So for alkaline solution, it will be the other case. So we would expect to have more hydroxide ion than hydrogen ion. Okay. And here, please pay attention to the representation. In chemistry, we use this bracket to represent the molarity of a substance. For example, if we want to represent the molarity or concentration of hydrogen ion, then we use a bracket and put H plus inside the bracket to represent it. Okay, so if we know the concentration of hydrogen ion, then we will be able to work out the pH value. Okay, so what is the formula that we use? Okay, it has been listed here. So the pH value should equal to minus log of the hydrogen ion concentration. Okay, and also we can rearrange and get this equation. That means if you are given the pH value, you will be able to work out the hydrogen ions concentration. So that would be 10 to the power of minus pH. Okay, so again, because of the format, it changed when I convert it into the PDF. So do check the Word version for the correct formula. Okay, so let's take a look at how we apply those two equations. So here, we commonly refer neutral solution that got pH 7. So how do we find out this magic number 7? Okay, that's because we measured the concentration of hydrogen ion, okay, at room temperature 25 degree and also 1 atmospheric pressure. So in neutral solution, we find that hydrogen ions concentration is equal to 10 to the power of minus 7 molar. Okay, so what is the pH value? So pH should equal to minus log of the hydrogen ion concentration. Okay, so here we know hydrogen ion concentration is 10 to the power of minus 7, so we substitute the number in. And if we put this equation into your calculator, we can work out the answer. The pH should equal to 7. So here I want you to pay special attention. Okay, this neutral solution have pH of 7 when it's at 25 degree and 1 atmospheric pressure. So if we increase the temperature or we change the pressure, then it will not have the same pH value. Okay, and okay, come back to this normal condition is standard condition, 25 degree and 1 atmospheric pressure. So we know neutral solution got pH 7 acidic solution got pH lower than 7, and then alkaline solution we got pH higher than 7. Okay, so here are some common examples in our daily life, and you should be quite familiar with those pH. Okay, at least a rough range how those what the pH number gonna lie between. Okay, so first you can see inside our stomach it got a pH around 1 to 2, so it's strongly acidic. That's because of the hydrochloric acid in it. And then we got Coca-Cola. It's a soft drink, so it contains a lot of carbonic acid, so again, so it's acidic. And for rain, normal rain, not acid rain, is also slightly acidic. Again, that's because of those acidic gas dissolved in it. Okay, and then we got milk. So remember, milk is also slightly acidic. That's because of the lactic acid inside it. Okay, so lactic acid we have mentioned in our previous unit. And then neutral solution at pH 7. And then we got alkaline solution. The soap that we use, the shampoo that we use, they're all alkaline solution. And some window cleaner, they are alkaline solution as well. Okay, and please note that pH value can go beyond 14 or below 0. Okay, so that's just a normal range that we use or used for most of the time. Okay, for the checkpoint questions, again, please pause a video here, attempt all the questions, and then come back for explanation. Okay, question 1. When pH value increases, what's the change for hydrogen ion concentration and acidity? Okay, so first, hydrogen ion concentration. Okay, when pH value increase, that means it become more alkaline. So it should indicate that the hydrogen ion concentration actually decreases. Okay. Okay, next one. Acidity. Again, as the pH value increase, that means the solution becomes more alkaline, hence the acidity should also decreases as well. Or you can think like this way, when the concentration of hydrogen ion decrease, that means it got less hydrogen ion in the solution. Okay, so the solution is less acidic than before. So acidity should decreases. The acidity should decrease. Okay. Question 2. Calculate the pH value of hydrochloric acid with hydrogen ion concentration equal to these two numbers. So for the first one, we know the concentration is 0.0001. Okay, so the pH should equal to minus log of the hydrogen ion concentration, which equals, okay, the way to represent this number can also be 10 to the power of minus 4. Okay, so how many zeros you have here is just to the power of that number. For example, I got 4 zeros here before the number 1, then it should be 10 to the power of minus 4. Okay. Anyway, if we put that equation into a calculator, we can get the answer. It should be 4. Let's try the other one, part B. Again, pH value should equal to minus log of the hydrogen ion concentration. Okay, and this time, because we only have 3 zeros in front of 1, okay, so it should be turned into 10 to the power of minus 3. Okay, so the answer will be 3. And from these two examples, you can see when the concentration of hydrogen ion increases by 10 times, pH value decreases by 1 only. Okay? And the reason for that is because the pH take log. Okay? So we know log of 10 just equal 1. Okay? So whenever your concentration increases by 10 times, when you take log, it would only change by 1. And this one is indicated by the pH value. Okay? So here, from A to B, we actually increase the concentration by 10 times. However, the pH value only decreased by 1. Okay? And then, question 3. The pH value of a sample for these two solutions. Okay, let's take a look at part A. Okay, so first we need to work out what is the concentration for hydrogen ion. Okay, so remember sulfuric acid is a diabasic. So that means one sulfuric acid would release 2 hydrogen ion. Okay, so it should be the concentration of sulfuric acid multiplied by 2. Okay, so it will be 0.20 multiplied by 2. That gives you 0.4 molar. Okay, so if we want to work out the pH, we just need to take log minus log of the hydrogen ion concentration. So that will be minus log of 0.40, and the answer should be roughly equal to 0.40. Okay, that's for part A. And for part B, okay, now we have H3PO4, phosphoric acid. So it's tribasic. That means the hydrogen ion concentration should equal to the concentration of the phosphoric acid multiplied by 3. So it was 0.2 multiplied by 3, 0.60 molar. And the pH value again equals minus log of the hydrogen ion concentration. So it would be minus log of 0.6, which roughly equals 0.22. Okay? And then, question 4. What is the concentration of hydrogen ion in a sample of the following example? Okay, so let's try part A, human blood. Okay, the hydrogen ion concentration, remember the formula should equal to 10 to the power of minus pH. Okay, so it would be 10 to the power of minus 7.4. Right, and then if we put the number in, it should give us equals 3 times 98 times 10 to the power of minus 8 molar. Okay, and for part B, again, same equation. Hydrogen ion concentration equals 10 to the power of minus pH, which is 10 to the power of minus 8.4. And it will equal to 3.98 times 10 to the power of minus 9 molar. Okay, and you can check that the the pH increased by 1. Okay, and the concentration also the concentration of hydrogen ion decreased by 10 times. Okay, pH value increased by 1, concentration of hydrogen ion decreased by 10 times. Then part C, right, this stomach acid hydrogen ion concentration equals 10 to the power of minus pH, which is 10 to the power of minus 2, so it equals 0.01 molar. Okay? And the last one, in each situation below where the pH value of the dilute hydrochloric acid change. First, add a piece of magnesium relevant to dilute hydrochloric acid. Okay, so for this one, after we add the magnesium into hydrochloric acid, it will undergo this reaction. Okay, remember to balance it. Okay, so that means hydrochloric acid is constantly removed from your solution. That means hydrogen ion concentration would decrease. If the hydrogen ion concentration decreases, that means the solution is less acidic. Hence, the pH value should increase. Okay, less acidic, more alkaline, so the pH value should increase. And then, part B, pass hydrogen chloride gas through dilute hydrochloric acid. Okay, so when we dissolve hydrogen chloride gas into water, into a solution. So originally hydrogen chloride is a gas, but after we pass through dilute hydrochloric acid, it would dissolve in water and form hydrochloric acid. Okay, so that means after we pass hydrogen chloride gas into the solution, there will be more hydrogen ions present in the solution. Okay, more hydrogen ion, more acidic, hence the pH value should decrease. Okay, then part C, add water to the dilute hydrochloric acid. Okay, again, let's think about it. Concentration, okay, concentration equals number of mole over volume, volume of the solution. Now here we got the same amount of hydrochloric acid. However, the volume, because we add water to it, the volume actually increased. That means we lowered the concentration. Okay, we lowered the concentration of hydrochloric acid, and hence we lower the concentration of hydrogen ion in the solution. If we lower the hydrogen ion concentration, that means the solution becomes less acidic, hence the pH value should increase. And for the last one, we're mixing dilute hydrochloric acid with HCl of same concentration. Okay, so with same concentration, so after mixing, actually we didn't change the concentration of the hydrochloric acid, okay, because it's of same concentration. So after mixing, no change of hydrogen ion concentration, so there will be no change for the pH value. Okay, so the next part we are going to discuss how can we measure the pH value of the solution. So there are several methods that we can use to determine the value of a solution, both given a rough number or an accurate number. So let's talk about the first type. Okay, first we can try to use acid-base indicators. So in the previous unit, when you do experiment, we've actually used some type of them. So we have used the pH paper and also we have used what's called the litmus paper. So the litmus solution is a kind of acid-base indicator. So acid-base indicator they are used to find the acidity and alkalinity of a solution. A few drops of indicator are dropped into the solution under test, and they show different colors in different pH ranges. Different colors. Okay, so before I introduce what we have here, they are chemical substances that we use as acid-base indicators. So right now, because we cannot go back to the school to do experiment, I want to introduce some natural indicator that can actually try at home. Okay, so here I got some examples. Okay, so here, the first example I want to introduce is the rose petals. So if you want to try the rose petal, actually you would not drop the samples onto the rose petal. You need to get the juice out from the petal, so you can grind it or you can squeeze it to get the juice out, and then it would show different color when you put in acid, maybe your vinegar, and also you can try the shampoo that you got at home. Yeah, that's the first one. And also we have the beetroot. Again, if we use a juice, that is a natural indicator. So it shows different color in acidic solution and in alkaline solution. And the last one here I want to introduce is the grape juice. Okay, again, you will not just drop the sample onto the grape. You need to get the juice, and then you try it with a different solution you want to test. Okay, so during this period, you can get some of these samples, some of these natural indicators, and try the color change. Okay, so if we go back to our notes, here on our notes, we actually introduced some chemicals that can act as acid-base indicators. So the first one is called litmus. Second one is called methyl orange. Third one is called phenolphthalein. Okay, so what are the color change you will see? I have attached a photo here. So it actually shows you what's the color change. So let's focus on the litmus here. So litmus, when in alkaline, so between 7 to 14, it will show a blue color. Sorry, litmus is the second one. It show a blue color. And then within this region, you can see a transition area. So that's a part that around 7 that you will see a purple color. Okay, and then when it gets into acidic parts, so below 5, below 5, you will see a clear red color for litmus solution. Okay, and then we have the methyl orange. It's the second sample here, methyl orange. So for methyl orange, at the alkaline part and also up to this region, you will see a yellow color. Okay, so it's in yellow. And then in the transition area, you can see it's got a orange color. And when in strong acidic condition, it will turn into red. And for the last sample, last type of indicator we use here is a phenolphthalein. So for phenolphthalein at basic condition, it will show a pink color. Okay, and in the transition area here, it will show a very pale pink. And then when you get closer to pH 7 or below pH 7, it would just show a colorless solution. Okay, because it's colorless, I would not be able to write with white, so I'll just choose black to write. Okay, so the exact number I don't expect you to remember, so I will not ask you whether methyl orange shows orange or red at pH 3.7. Okay, there is no need to memorize the exact value, but you should be able to tell what's the color in acidic condition and what's the color in alkaline condition. Okay, so let's check your understanding by completing these three equations. So pause the video here and check your answer. Okay, the first one, excess sodium hydroxide have been added to hydrochloric acid with methyl orange. Okay, so at the beginning, we got hydrochloric acid with methyl orange, so it should show a red color. Okay, that's at the beginning because it's in acidic solution. And then we have add sodium hydroxide solution in, so it would neutralize the hydrochloric acid, and because we are adding excess, so more than enough sodium hydroxide to neutralize it, but we added more. Okay, so the solution will actually turn into an alkaline solution eventually, and for alkaline solution with methyl orange, it will show a yellow color. Okay, part B, we have potassium hydroxide solution with phenolphthalein, and then we neutralize it by adding just enough amount of dilute sulfuric acid. So at the beginning, we have potassium hydroxide solution with phenolphthalein. So we are adding phenolphthalein into an alkaline solution. So it will show a pink color at the beginning. Then we adding just enough amount to neutralize it. So at pH 7 for neutral solution, it would just show a colorless solution. Okay, and for part C, hydrochloric acid with methyl orange is neutralized by just enough amount of sodium carbonate solution. So sodium carbonate solution is slightly basic. Okay, so first, at the beginning, we have hydrochloric acid with methyl orange. So methyl orange added to an acidic solution, so it should show red color at the beginning. And after we add just enough sodium carbonate in it, so it will have neutralization reaction and the pH should turn into pH 7, and then methyl orange should show a yellow color. Okay, that's for the acid-base indicator. So for acid-base indicator, it would just give you a rough range of the pH value. So we can use the pH paper to give you a more accurate, okay, a narrowed range of the pH value. So if you want to use the solid version, then it will be the pH paper that you have tried before, or you can use it in a liquid form, then it will be the universal indicator. Okay, so to get the pH value, the color we are getting from the solution will be compared with the pH color chart, which I have attached a graph here to show you the color. Okay, so at strong acidic condition, it will show a red color. Okay, and for the middle part, we say it's slightly acidic, then it will show the orange color. And then if we further increase the pH, we would move on to this region. So it shows a yellow color, then we would say it's weakly acidic. Okay, it's just a way that we compare its acidity. Okay, and then we further increase up to neutral, then we get a green color. And then we increase a little bit to blue color, then we again say it's slightly alkaline. And then further to the region that we have a pH value of 14, then it becomes purple. So for blue, we describe the solution that shows a slightly alkaline condition. Okay. And also we can again use some more advanced instrument to help us measure the pH value accurately. So here we got the pH sensors. Okay, so the pH meter or the data logger with a pH sensor can be used to measure the accurate pH value of a solution. Okay, so for the pH meter, it will just show the sample. But for the data logger, later you will do experiment for which is called titration. So experiment between acid and base, but we're constantly adding for example, base into acid. So if we put this type of pH sensor with a data logger, so it can take the reading at, let's say, each 2 seconds. It can take a reading and plot a graph for you. So data logger is very powerful in science, and we use it in a lot of areas to do experiment. Okay, and for this kind of pH sensor, actually there are some requirement and some steps, techniques that you need to learn to deal with it. And if we got time to use them in our experiment, I'll teach you in details.